Ever look back at old photos, from way back when and think, wow, where did the time go? Like, wouldn't it be incredible if our bodies could just hit the reset button just like that?
It'd be something else, that's for sure. And the funny thing is, that's kind of what scientists are trying to figure out.
It's wild, right? Not just some science fiction movie plot anymore. This is real science happening right now.
Yeah.
And some seriously big names are throwing money at it. So we figured, let's break it down for everyone.
The first thing you got to wrap your head around is that aging, it's not just about wrinkles or gray hair, right? It's way more complicated than that. We're talking about what's going on deep down at the cellular level. Our cells, those little guys, they kind of start to lose their mojo as we get older.
So like an old car. Parts wear out, things start making funny noises.
Exactly. Every time our cells divide, it's like making a copy of a copy. Eventually, those copies get kind of fuzzy, lose their sharpness. Same thing happens inside us. Those errors start adding up and boom, wrinkles, you name it. And it's not just on the outside either. It's our organs, everything.
Makes you think twice about that next birthday, huh?
Yeah.
But where do stem cells fit into all of this? Stem cells, they're like the rock stars of the cellular world or something.
Stem cells, they're the blank slates of the body. When we're just starting out, just a little cluster of cells, stem cells can become anything. Heart cells, brain cells, you name it, total overachievers.
So they've got youthful potential, like those kids who are good at everything they try.
But here's the catch. As we grow up, those stem cells, they start picking their career paths. They become specialists, muscle cells, skin cells, whatever the body needs at that moment. And listen, this specialization thing, it's crucial, right? But it comes with a trade-off.
Let me guess. They lose that youthful flexibility.
You got it. They lose that ability. And to top it off, we have fewer stem cells as we age. And the ones we do have, well, they're not as sharp as they used to be. That's why we start seeing telltale signs of aging. Our bodies can't keep up with the repairs as well as they used to.
Kind of a bummer, right? But scientists are now finding ways to reverse that specialization, turn back the clock on those cells, make them young again. That's where cellular reprogramming thing comes in, right?
Yeah, this is the groundbreaking part. Back in 2012, a scientist named Shinya Yamanaka, really smart guy, he found 4 specific genes, we call them the Yamanaka factors now, that can basically hit the reset button on a cell, taking an old, tired skin cell and saying, hey, remember when you could be anything you wanted?
He found a way to make cells act young again.
It's a huge step. He even won a Nobel Prize for it. But let's not get ahead of ourselves. We're not talking about turning back time completely. Not yet, anyway.
Okay, so no Benjamin Button situations for now. But this reprogramming thing, it's still a big deal, right? Imagine being able to reverse diseases, fix damaged organs, all because we can make cells young again.
Oh, the potential is huge, no doubt. And that's what has scientists so excited, especially this idea of partial reprogramming.
Partial reprogramming. So not a full rewind, more like a targeted tune-up.
Imagine zeroing in on specific organs, specific tissues, and just reversing the aging process in those areas. Instead of a complete overhaul, we're talking about targeted tweaks.
I like the sound of that. So is anyone actually doing this? Any real-world examples of this partial reprogramming thing in action?
There are some cool things happening. There's this scientist, Dr. Johnny Hurd. He's using stem cells to help athletes repair their joints, like after a bad injury.
Athletes, they definitely put those joints through the ringer.
And it's not just about fixing the damage. It's about making things work better than before. And Dr. Hurd is also looking into these things called epigenetic drugs. So epigenetics, think of it like this. You've got your genes, right? Your DNA. But then there's this other layer of information that sits on top of your genes, kind of telling them what to do, how to act. These drugs, they mess with that top layer.
So we're changing how they express themselves. We're basically tricking those cells into acting younger. Gotta ask, who's paying for all this? This kind of research doesn't come cheap.
Good question. And this is where it gets interesting. Some seriously big names in the tech world are pouring money into this stuff. Not just university labs and research grants here.
Okay, who are these tech titans and what are they hoping to achieve?
Well, get this. One of them is Jeff Bezos.
Jeff Bezos. Mr. Amazon himself.
The one and only. He sunk a bunch of cash into this company called Altos Labs.
Altos Labs, huh? Never heard of it.
They're pretty secretive about what they're up to, but the gist is they want to reverse aging and disease.
And how are they planning on doing that?
Cellular reprogramming, of course.
Figures. So what's the angle here?
It's a question a lot of folks are asking. And Bezos isn't the only one. You mentioned the ChatGPT guy earlier.
Sam Altman. Yeah, what about him?
He's throwing his hat into the ring, too, investing big time in a company called Retro Biosciences.
Retro Biosciences. Okay. What's their deal?
Their whole thing is increasing health span.
Health span, not lifespan.
Right. It's not just about living longer. It's about feeling good, being healthy for as long as possible.
But let's be real. All this research, these investors, does that mean regular people are just going to be left in the dust?
It's a conversation we need to have, for sure. But even if we set aside that whole can of worms, we got to consider the risks.
Risks.
Yep.
We're talking potential downsides to all this life-extending technology.
Exactly. Cellular reprogramming, it's powerful stuff, but with great power
Comes great responsibility. Okay, I see where you're going with this. What are the risks? What could go wrong?
Well, one word: cancer.
Cancer. Seriously. Not exactly what I want to hear when you're talking about anti-aging.
Right. But remember those Yamanaka factors we talked about? Turns out 2 of those genes, they're also what we call oncogenes.
Oncogenes. That doesn't sound good.
It's not. They're basically genes that can cause cancer if they get messed up.
So by using these Yamanaka factors, are we basically messing with the cancer button?
That's the worry. Scientists are trying to figure out ways to make it safer, but it's a real concern. And cancer isn't the only potential issue either.
There's more. Okay, lay it on me. What else could go wrong?
Honestly, we're still in the early stages here. We don't know the long-term effects of messing with our cells like this. There have been some studies, some hints that maybe it could lead to organ problems down the line, other stuff we haven't even thought of yet.
So it's a bit of a gamble then.
You could say that. Exciting, but definitely some risks involved.
All right, so we've got cellular reprogramming, billionaires trying to cheat death, and the possibility of accidentally giving ourselves cancer. What else could we possibly add to this mix?
How about a little artificial intelligence?
AI. Now, AI is getting in on the anti-aging game.
Big time. AI and machine learning, they're changing everything. Scientists are using them to sift through mountains of data, looking for new ways to target aging. And they're finding some really interesting stuff. One area where AI is making waves is in the development of something called senolytic compounds.
Senolytic compounds. Sounds intense. What in the world are those?
As we get older, our bodies start accumulating these sort of zombie cells. They're not quite dead, but they're not exactly alive either. They just hang around, causing inflammation and making a mess. And the older we get, the more of these zombie cells we have. But here's where the senolytic compounds come in. They're like zombie cell assassins. They take them out, clean up the place.
Okay, that sounds pretty useful. So where did the AI come in?
AI is helping scientists find these senolytic compounds. They feed tons of information into these AI programs, like a giant database of chemical compounds, and the AI looks for anything that might have those zombie-killing properties.
So it's like a high-tech treasure hunt with AI as the map.
Exactly, and it's working. There was this one study where they used AI to analyze 800,000 different compounds.
800,000! And they found something.
They found a handful that showed real promise as senolytics. It was a huge breakthrough. And we're just scratching the surface. This whole field of aging research, it's moving so fast, it's hard to keep up. One thing's for sure, things are about to get really interesting.
It's a brave new world we're stepping into, isn't it? This idea that maybe, just maybe, we're on the verge of actually controlling aging. Yeah. It's exciting and kind of terrifying at the same time.
Absolutely. And it makes you think, what would that even look like? A world where people are living hundreds of years. Our whole society is built around this idea that our time is limited. What happens when those limits start to disappear?
It's almost impossible to imagine, right? All our stories, our art, our history. It's all about this finite existence we have.
Right. So if you take that away, what happens to our art, our creativity, our understanding of what it means to be human? It's a mind-boggling concept.
Definitely makes you think. But even if we just focus on the practical stuff, the implications are huge. Yeah. Imagine the strain on resources, the environment. And don't even get me started on what happens to things like retirement and Social Security.
It's a whole different ballgame. And how do you even begin to address the social implications? Imagine the divide between the haves and have-nots, the people who can afford these life-extending treatments, and those who can't. It's a real concern, and these are conversations we need to be having now, before it's too late.
Couldn't agree more.
Yeah.
So where do we go from here? What can people listening do to stay informed, to stay engaged with all of this?
It's simple, really. Stay curious. Read everything you can get your hands on. Follow the research. And don't be afraid to ask the tough questions.
I like that. Stay curious. Because this is a journey we're all on together, right?
That's right. The future of aging, it's the future of humanity.
Well said. And on that note, we're going to wrap up this deep dive into the world of cellular reprogramming. Hopefully you're as fascinated by this stuff as we are. It's a wild ride, but it's just beginning. Thanks for listening.